Tanya. Is there anyone else that you're expecting?
I think we're good.
Okay, I think we are too. So with that, amazing Waipahu High School students, SWIP interns, go ahead and wow us with your presentation.
Thank you. Okay. Hello, everyone. My name is Harvey Picard, and I'm the business supervisor.
Hi, I'm Tiani Perez, and I'm the drain sampling coordinator.
Hi, nice to meet you all. My name is Jan Cornelio. I am the equipment manager.
My name is Aaron Panett, and I'm the assistant equipment manager.
Hi, I'm Kenichi, and the documentarian.
And we are juniors at Waipahu High School's Academy of Engineering, and we participated in the SWIP internship.
SWPPP, also known as Stormwater Pollution Prevention Plan, is a system to help reduce pollution in our drains and oceans. By evaluating the drains in our own school, we get a clear idea on what goes on in Hawaii's waters, more specifically, Pearl Harbor.
After going through the step-by-step process, the goal at the end is to implement BMPs, which we will talk more about later. BMPs are basically solutions to the pollution problem. Our main purpose with this presentation for you is to ask for your acceptance with our best management practices, as it will improve the stormwater quality of Waipahu High School.
The first step in the SWIP project is to define the watersheds that we're working with. The overarching watershed of Waipahu High School, it's all leading towards our sort of specific watershed. A watershed is defined as the area of land where water within it is diverted into a singular source. That is when runoff leads to a body of water, such as a lake, river, or ocean. In the case of Waipahu High School, it would be Pearl Harbor. So we are split into groups and assigned specific drains to figure out what our smaller watersheds are. We then had to figure out how and where the water flows in order to understand the area the water touches before it reaches the drains. We did this by choosing 5 points around our drains, marking it with a cone, and dropping a tennis ball straight down in order to see the water flow or predict the water flow before reaching the drain. It's important to start with these smaller watersheds first before tackling the larger watershed it's a part of. As mentioned previously, all of the drains in our school lead to the ocean. It's better to start cleaning these specific drains first before cleaning the entire ocean.
With the research portion of SWIP, we studied the pollutants that could appear in the drains for future lab tests. The pollutants include TSS, total suspended solids, BOD, biochemical oxygen demand, oil and grease, nitrate and nitrite, and total coliform. We also studied storm drain anatomy, the history of water quality in the US, and SWIP in other schools on the mainland. In addition, we did many activities in our classroom to prepare for what we might see inside our drains and watch videos on how to properly clean the area around the drain and its gate and how to collect stormwater samples.
Part of the training is identifying the different types of storm drains and learning its anatomy. So we needed to learn how the pollution enters through the inlet drain, the catch basin, and the outlet that links to our nearby ocean. When we do go out for our monthly visual observations, we make sure to wear personal protective equipment, PPE, protective eyewear and gloves for safety while we handle sharp equipment like screwdrivers. The main task is to describe the pollution around the drain and inside of the drain, then figure out where it came from. One example for the lunch drain, there have been a couple of times where we saw orange peels.
It's over already. Mahina, can you please mute your... You're not muted. Thank you.
Sorry. One example for the lunch drain, there have been a couple of times where we saw orange peels and plastic wrappers that it may have been from the cafeteria. Lastly, we need to mention if there needs to be actual maintenance, or if we need extra help, and then weigh the amount of trash on a scale. It's important to do this monthly in order to compare results and suggest potential sources of trash. We discuss past and future events in which we could gain more pollution, like trash from safety and spring fairs, or from our spirit days like Arthur's Awards.
The other task that all of the drain groups needed to complete was collecting a rainwater sample to be sent out to the lab. In our training of inspecting the stormwater, we watched a very helpful YouTube video on how to conduct a sheet flow sampling. In short, it was to take a weighted object, sandbags preferred, and lay it about a resting plastic sheet where water could run through. With the two bags, it forms a funnel system that guides the water into the drain, where a person with a 2-gallon bag can collect the water from. As the drain sampling coordinator, I was taught how to fill out the chain of custody. The definition of chain of custody, in terms of water sampling, is a type of testing in which all individuals who handled the sample are documented on the chain of custody form that showed unbiased professionals had access to the sample. I worked with all the different drain groups to fill out the information about their samples. Different drains were tested for different purposes, such as TSS, BOD, oil and grease, etc.
So now we're going to talk about the pollutants we tested for. First up, we have biochemical oxygen demand, also known as BOD, which measures the demand for dissolved oxygen in the water. The greater the BOD, the more rapidly oxygen is depleted in the waterway. This means less oxygen available for aquatic life.
To your left is the lunch stormwater sample lab result. The left bar will always be the EPA benchmark. Here, the lunch drain BOD result is under by 26.1 milligrams per liter.
Next, we have coliform, which is a bacteria commonly found in bird and animal feces. In the waterways, excessive amounts of coliform deposited and washed into the ocean can cause beach closures. If ingested by humans in high concentration, it can cause illnesses such as nausea, vomiting, diarrhea, fever, and loss of appetite.
And to your right is the roof stormwater sample lab result. The total coliform at our roof drain is safe at 2,419.6, which is over 7,580 colonies less than the benchmark.
Next is nitrates and nitrites, which are found in most chemically composed and organic fertilizers, pesticides, and herbicides from the grassy fields of our school and baseball field. It causes algal blooms where algae reproduce at a rapid rate. This might sound like a good thing, but there are some algae that are toxic, and when their growth is increased, so is the amount of toxins added to the water.
To your left is the field stormwater sample lab result. Our field drain is greater than the benchmark by 3.38 milligrams per liter.
Next, we have the Next, we have oil and grease. The type that ends up in the oceans are commonly found from parking lots and roadways. Cars that are poorly maintained will produce the most. One major effect oil and grease has is it tends to float on the water surface, but can also adhere to plant life along their path, reducing oxygen production for the plants.
And to your right is the parking lot stormwater sample lab results. Our parking lot drain is well below the benchmark and is safe by 10 milligrams per liter.
Lastly, we have total suspended solids, also known as TSS, which is typically caused by sediment entering the drain from a planter, field, foot traffic, or intentional discharge such as sweeping or children kicking dirt in the drain. TSS can be the most damaging since it can make its way into the stormwater drainage system and can settle and clog pipes, which can lead to blocking water flow and contribute to potential flooding.
All of the drains are tested for TSS, total suspended solids, which the benchmark is 100 milligrams per liter. The only ones greater than the benchmark is parking lot at 388 and the field, especially high at 700 milligrams per liter. However, below the benchmark and are slightly safe are the lunch drain with 36, high traffic at 43, and the roof drain at only 4 milligrams per liter. The fact that the results are not zero is enough to bring awareness to the stormwater pollution and create best management practices. Waipahu High School is only one of many locations and could be far less demanding than others that we need to start now in making sure that everywhere in our community is safe from these pollutants that were previously mentioned.
Aside from the waiting, part of the SWIP plan is to conduct our own in-classroom experiment testing for all of these. By completing a rain sample visual inspection form, we also take into account the qualitative data, so that includes color, odor, clarity, TSS, oil sheen, and any foaming. As for the quantitative data, we hope to score an average of 4 from the categories you are viewing, like water appearance, total coliform if there is any, and pH if it's a 7. We used several tablets that performed the test, and we compared our results to the SWIP charts provided.
Aaron, your mic is off.
During drain maintenance, there are often challenges or issues that during our inspection. Parking lot drain had a unique problem of cars often covering or blocking more sides of the drain.
Aaron, you're gonna have to restart and then fix your mic a little bit. Can't hear you, sorry.
Okay. During drain maintenance, there are often challenges or issues that arose during our inspections. The parking lot drain had a unique problem of cars often covering or blocking one or more sides of the drain, making it harder to remove the drain grate to perform our maintenance. We also discovered that runoff oil or debris coming off of the cars go into the drain, which was a possible source of pollution. The field drain was located in the lowest point of a grassy and muddy field. The nearby area surrounding the drain often caused sediment buildup and other issues, covered up by grass trimmings and dirt that was sometimes displaced during rain events. The grate for the drain was also very heavy and nearly impossible to remove, which made maintenance very difficult for us to perform.
For the drain I primarily focused on, our main concern is that this hole that we call a storm drain inlet actually leads to the field nearby. At one point, our peers shined a light through the pipe where we found a light at the end of the tunnel. The field was about 8 feet away, so all of the trash and sediments would flow into what seems to be a bioretention drain. However, this does flow right into a nearby parking lot drain too. Also, the topography, the leveling of our drain makes it easy for it to be flooded. And it doesn't help that it's constantly being covered with grass clippings and mud. So when people litter with their milk cartons, lollipop wrappers, etc., it just becomes layers that leads to flooding. The very popular drain, the high traffic drain, where it is in the middle of the field, surrounded by the buildings and in an area with soil, from the monthly observations, we can conclude that the soil erosion gets into the drain. We realize that if the sediments pile up over 2/3 under the outlet, it should be cleaned. After X amount of years, and as seen in the picture on the right, the trash and soil sediments already reached the bottom of the outlet. Sooner or later, the sediments will flow into the pipes, clogging it, then causing a flood, which is highly unwanted.
This drain didn't have many challenges because it was in a pretty remote place, just a few classrooms surrounding it. We found some articles of clothing, plastic rubbish, and pieces of rubber around the drain. This could be because of homeless people on the campus or students carelessly discarding trash because there aren't any trash cans outside. Near the classroom is a gardening area, which also contributes to how much sediment goes near the drain, which can make the leveling of the drain uneven and not flow smoothly.
After inspecting and maintaining our drains over the course of 2 months, the next step of the SWIP project began, which was to create BMPs or best management practices. BMPs are split into two separate categories, source and treatment. Source control BMPs are ways on how we could educate the public about SWIP and how they could protect their local storm drains. Treatment control BMPs are actually designing and implementing our own ideas into the micro watersheds that prevent pollution from entering through the catch basins. For one, all of the SWIP interns must perform good housekeeping by getting rid of any blockage from the grates and picking up trash from the surrounding areas, lifting the grates to clean the catch basin, etc. For example, in the right side of the slide shows a before and after picture of the parking lot drain in front of V building. The grate was extremely dirty, having been covered with layers of mud and sometimes nuts and leaves from nearby trees. Cleaning the catch basin inside of it was something we could not do as we were unable to pull out the grate because it was suctioned into the mud, though we still tried our best to move forward with cleaning it. Other BMPs that we have done will be highlighted in our next slides.
Our initial proposed source control BMPs consisted of flyers to give statistics, data, and information to the community. Social media was another effective source to reach more people through platforms widely used, such as Instagram. We could then make educational videos, memes, and infographics and post it on our social media account. Then we could advertise our accounts through the school newspaper and bulletin. Our last proposed idea was to hold a booth at our school fairs that would give information and spread awareness. As for our proposed treatment control BMPs, it varies depending on the drain's location. The lunch drain group was looking at some way to correct the ground, allowing water to flow into the drain efficiently and not pool in random places. For the roof drain, bird spikes added to the roof would hopefully lower the amount of coliform and also a drain gate is needed to keep dirt and soil out. We'd also like to have annual checkups to replace the biostocks at the field and high traffic drains. At these locations, the level of soil builds up more than compared to the other drains. Replacing the biostocks would prevent further soil sediments from entering the drains, as well as lowering the amount of TSS, nitrate, and nitrite. For all the drains in general, regular maintenance is necessary, such as cutting grass and removing weeds in the area, as well as any debris that comes into the area or obstructs the drain. However, with the unseen circumstance of COVID-19 shutting schools down, many of our proposed BMPs were no longer in the realm of possibility. With the stay-at-home order, we decided to put our focus on the SWIP Instagram account due to everyone being stuck at home and the majority of people spending some part of their day on social media, allowing us to expand our audience.
Under the source control BMPs, we separated it into educational and community outreach. For educational outreach, we created a video introducing SWIP to our Twitter following. We hope to make more videos in the future to showcase what we have been doing and our purpose. Secondly, we created a Waipahu High School SWIP account on Instagram as mentioned previously. Here, we post home sustainability challenges such as ways to compost at home, prevent ocean pollution, and more. To reach more people, we then repost it on our personal accounts. Lastly, during the stay-at-home order, we created several flyers with pictures or facts that educate the public located on the right of the slide. Had we been given more time without the quarantine, we could build relationships with other SWIP teams and water pollution prevention organizations to further our research into the detrimental effects of pollution in our local waters.
Hi, let's look back at Waipahu High School. Yes, yes. Oh, and would you look at this stadium? Yak, ano yun? You mean the trash from school goes over there? This turtle should be eating fish, not plastic. There's more. However, meet your stormwater pollution prevention plan team. We basically open the grate, take out the grate, and go inside the grate to clean inside it. And we collect water samples at various locations and test them. Remember her? We cleaned her. We need to remember to keep these clean before it rains. Easiest way to do that is to throw away your trash. If you do that, then you're amazing.
So that was one video made by our SWIP intern. You can easily find it on our Instagram page at Waipahu Stormwater. It is the most recent post right now. So the next category is community outreach. We hope that by starting small with our ideas of creating a sticker and sharing additional information on our Instagram account, it can gain traction and attention to protecting our storm drains. This sticker could be distributed to be placed on people's hydro flasks or trash cans. The Instagram account also follows other SWIP accounts from the mainland and uses different hashtags to shed light to our public account. Again, without the quarantine, we could have raised this project to go to local schools and educate the younger students about this.
The success of our stormwater pollution prevention plan was not a task we hoped to achieve on our own. Lauren Roth-Venu from Roth Ecological Design International tells us about how our company works with implementing their own BMPs into practice, teaching us about some practical forms BMPs can come in and the impacts of these changes. Patty Diaz took charge of the project as a whole and directed us in what we had to do as SWIP interns and what our goals should be. The WE board provided us with substantial feedback and support in any of our endeavors. And lastly, the joint collaboration between the Academy of Engineering and Academy of Natural Resources in the actual implementation and fieldwork of our project made everything work.
Finally, we'd like to thank our partners for making our time with the Stormwater Pollution Prevention Plan successful. Thank you very much for your time, and we'd love to hear your feedback.
Thanks, guys. That was a really great presentation.
you.
Sherry, you can go ahead and stop the recording now, please.
Okay, I'm stopping it.